In this video, we are going to discuss about the gate question, which is related to control system course. The question is, the block diagram of the closed loop control system is as shown in figure. The value of K and P such that the system has a damping ratio of 0.7 and an undamped natural frequency of omega n of 5 radians per second or respectively equal to. From this question, we want to find out K and P values. The given values are damping ratio, that is zeta is equal to 0.7, and then undamped natural frequency, that is omega n is equal to 5 radians per second. Okay, this is the given block diagram. Let us see how to solve this problem. Okay, um, from this block diagram, we can say that G of s is equal to K divided by S into S plus 2. And h of s is equal to, that is the feedback transfer function, is 1 plus s into 1 plus s into p. Okay, then for closed loop transfer function, this is a negative feedback system, so the closed loop transfer function will be written as g of s c of s divided by r of s is equal to g of s divided by 1 plus g of s into h of s. So we will substitute g of s value is equal to k divided by s into s plus 2, and h of s is equal to 1 plus s into p. So we are uh, substituting here. Then we are taking LCM in the denominator part. If you take LCM in the denominator part, we will get k by s into s plus 2 in numerator as it is. In denominator, it will be changed to s into s plus 2 plus k into 1 plus sp divided by s into s plus 2. So numerator as well as denominator have s into s plus 2 terms are common, so it will be cancelled each other. So we will get k divided by s into s plus 2 plus k into 1 plus sp. Now I am multiplying each terms in the denominator part. So we will get s squared, s into s squared, s into 2 2s plus k into 1 k into spk I have written. Okay, next I'm rearranging the equation denominator part in s square term and then s term and then constant term. If I do like this, I'll get s squared plus s into 2 plus pk plus k. This is the way I'll get the values. We know that the characteristic equation of the standard second order system is s squared plus 2 zeta omega ns plus omega n squared. In our problem, we got the characteristic equation value as s squared plus s into 2 plus pk plus k. So we will write like this. Okay. Compare these two equations. We'll get k is equal to omega n squared. K is equal to omega n squared. Next, 2 plus pk is equal to 2 zeta omega n. 2 plus pk is equal to 2 zeta omega n. We know that the zeta value is 0.7 as well as omega value is equal to 5 radians per second. Substitute omega n is equal to 5 here, so k is equal to omega n squared, so 5 squared is equal to 25. Then 2 plus pk is equal to 2 zeta omega n. Zeta value is 0.7 and then omega n value is 5, so we will get value as 7. pk is equal to 7 minus 2 is equal to 5. Then in substituting k is equal to 25, so p is equal to 5 divided by 25. It's equivalent to zero point 0.2. Hence k is equal to 25, p is equal to zero point 0.2. It is in the option D. The answer is option D. Is the gain margin of a unity feedback control system with the open loop transfer function g of s is equal to s plus 1 divided by s squared is option A 0, option B 1 by root 2, option C root 2, and option D is infinity. From the question we have to find out the gain margin for the given transfer function. Let us solve the problem. The given transfer function g of s is equal to s plus 1 divided by s squared. Let us put s equal to j omega, then we will get g of j omega is equal to j omega plus 1 divided by j omega squared. First of all, we have to write the magnitude equation, that is nothing but modulus of g of j omega is equal to square root of omega squared plus 1 divided by omega squared. Then we have to write the phase angle equation, that is nothing but angle of g of j omega is equal to tan inverse of omega. From the numerator j omega plus 1, we will write tan inverse of omega by 1 and minus 180 degree. This is nothing but for denominator part j omega squared. Okay, so we will write tan inverse of omega minus 180 degree. That is the phase angle equation. By definition, omega pc is nothing but a phase crossover frequency. The frequency at which the phase angle is minus 180 degree is called as phase crossover frequency. Okay, that is nothing but we can write it as g of phase angle of g of j omega pc is equal to minus 180 degree. Okay, hence the phase angle equation is equated to, that is equation number 2 is equated to minus 180 degree by the definition of phase crossover frequency. Okay, that's why we have, instead of omega, we are substituting omega is equal to omega pc in this equation. So tan inverse of omega pc minus 180 degree is equal to minus 180 degree. Tan inverse of omega pc equal to minus 180 degree plus 180 degree, because that minus 180 degree is coming to right hand side. So tan inverse of omega pc equal to 0 degree. Omega pc is equal to tan 0 degree. Tan 0 degree value is 0. Next, we know that the gain margin is defined as the reciprocal of g of j omega. That is nothing but magnitude of g of j omega at omega equal to omega pc. That is the definition for gain margin. We know that the magnitude of the given transfer function is g of j omega, modulus of g of j omega is equal to square root of omega squared plus 1 divided by omega squared. That's why we have written like the here like this. Then we want to find out magnitude of transfer function at omega equal to omega pc. Hence I am substituting omega is equal to omega pc in this equation. Hence g of j omega at omega equal to omega pc is equal to square root of omega pc squared plus 1 divided by omega pc squared. Now we know that omega pc value is 0 degree, 0 value. Then we substitute omega pc is equal to 0 in the above equation. Hence g of modulus of g of j omega pc is equal to square root of 0 plus 1 divided by 0. We know that 1 by 0 is equal to infinity. Then gain margin is equal to 1 by magnitude of g of j omega at omega equal to omega pc. We got g of j omega at omega equal to omega pc is equal to infinity. Hence 1 by infinity is equal to 0. So the option is uh, option A is the correct answer. A equal to 0. Thank you.